Well, I think that's just about who's going to be here. So thank you. Welcome to the last day post-food coma session. And there were some hard choices, session choices, this afternoon, so we thank you for coming to see ours. My name is Greg Rolan. I'll explain who I am a little later. But to start with, I'd like to acknowledge that we're meeting on the unceded lands of the Whadjuk Noongar people and pay my respects to Whadjuk elders past, present and emerging. We've got a little bit of housekeeping. I'm obligated to say that there are still t-shirts for sale for $20 and books for $10 at the registration desk. If you wish to partake in drinks this evening, again, sign up at the registration desk. And I believe the credit card that was lost is still lost. You found it. Okay, so I can cross that one off. Throughout this conference we've been, I guess, teased with visions of a artificial intelligence future, particularly Tim this morning. And so this afternoon we're going to talk about some techniques and tools that are actually being used today. But before we get into that, I'd like to introduce the panel members. And I should mention that our industry being what it is, most of us aren't in the role that we were when we submitted this and wrote our paper together. So these bios are a little bit ephemeral. So we have Glen. Glen, do you want to wave? Glen Humphries is as of this week, a project officer with the Digital State Archive of New South Wales, State Archives and Records. He's previously worked for Archives New Zealand from 2006 to 2014, where he gained a wide knowledge of archival practices before moving to Australia in 2014. Glen joined the Digital State Archive in 2015, has been working on a number of digital transfers of various sizes and ages. And as you'll hear today, Glen also has been currently leading pilot projects looking at the capabilities of machine learning technologies in records management, specifically in disposal of structured and unstructured data. Lisa Jeffrey is a Melbourne-based information professional. She was engaged at the Public Records Office of Victoria on machine-assisted appraisal. She's got over 10 years experience as a records manager, archivist, information strategist across private and public sectors, both federal and state. Has completed graduate and postgraduate study at Monash University. Yay. Lisa is interested in how and why individuals self-document or don't in different contexts and how technology can support organisational and community memory. And Lisa's currently now working at RMIT in Melbourne. And we have Tatiana at the end there, Tatiana Antsoupova. She's the Acting Chief Information Governance Officer at the National Archives in Canberra. She's been working there since 2005, and before that was the Archives Officer at Noel Butlin from 1996 to 2005. Before that, she was a government archivist in Russia. She has a degree in Archives and History from the Moscow State Institute of Archival and Historical Studies, now the Moscow State University of Humanities. And I found this really interesting. Spent 1 year at the University of Pittsburgh studying archives and records under Professor Richard Cox, which means you're a postdoc in grumpy old white men. Yeah. And I should advance this a bit. And myself, Greg Rolan, I've had a career in IT. I'm a bit of an interloper. From large corporations to my own startup. Was a little bit burnt out from that, returned to study to become a librarian and was drawn into the heady world of record keeping and archives. I'm now a researcher in record keeping systems design. Today I will use the word record keeping to mean everything from deciding which records should be created in the first place to their ongoing preservation. Or not for utility as long as they're needed. You know, I'm of a certain age where, as a youngster, I read a lot of science fiction and I'm now seeing it all come true. which places me in a really quite cool place. And one of the aspects of the science fiction world is this sort of promise of artificial intelligence in all sorts of ways. I actually should have turned this into a quiz last night, see who could pick the various artificial intelligences. So we've been, it's been dangled in front of us for a long time now. And so what we're trying to understand today is what's the fact and what's the fiction, and what are people actually trying to do today. The fiction has become reality. Not a day goes by without breaking news of some AI advance. And beyond the realm of research, this stuff is actually breaking the halls of research into consumer land. Surely we're entering a golden age of AI-assisted automation in all facets of our lives. But as record-keeping professionals, we can ask, what about us? Where or what is the AI automation that's helping us with our classification, appraisal and disposal work? And if AI can help drive our cars and diagnose diseases and filter our personal information needs, surely we can use it to address the routine aspects of our work and attack our growing backlogs. If not, reconfigure our discipline in line with the realities of digital record keeping. Arguably, if we're going to meet the challenges of managing records in the digital age, such technological assists, together with the skills and knowledge required to wield them, will be necessary. In this panel, we'll provide a snapshot of the practice of AI in Australian record keeping. What's the reality versus the hype? And we could have given a whole talk on the way this particular curve has changed over the last couple of years and which buzzwords have appeared and disappeared from the vernacular. What's the reality versus the hype, and what's being done now? So today I'm going to be quite didactic and give an overview of AI and some technologies, just so we understand kind of how it actually works and what some of the words really mean. And then we're going to look at 3 case studies from State Records Archives New South Wales, PROV and the National Archives. And then we'll conclude with some Q&A where I hope you'll ask lots of pointy questions, and we'll do our best to try and answer that. So, artificial intelligence has evolved since the early days of computing and before, I guess. But due to its ever-shifting nature, it defies easy definition. Part of the problem is that as people become accustomed to automation, it stops being considered AI, and newer technology takes its place. This constant churn means that in one sense, AI ends up being the stuff that AI people do, right? Which is quite complicated. So for the purposes of this panel, we will understand AI as involving digital systems that automate or assist in activities that we associate with human thinking, such as decision-making, problem-solving, learning and creating. In fact, we take the view that AI manifests on a multi-dimensional spectrum comprising scale, speed, degree of autonomy and generality, and encompasses a wide range of actual technologies and techniques. So one way to sort of break all this down and think about types of AI is to consider the role of domain expertise and the way and the manner in which this knowledge is actually embodied within an automated system. And our taxonomy encompasses rule-based systems, statistical model systems, and deep learning systems. And I'm sure you've heard those terms before. And while this is kind of a useful taxonomy to sort of draw out some of the distinctions of the tools, you've got to, in the real world, implementations might comprise one or more of these things with hybrid combinations. So what I'm about to tell you is all true, but it's possibly a simplified account. So rule-based systems, sometimes called expert systems, because they rely on the elicitation and articulation of domain expertise. So an expert is quizzed, their knowledge or many people's knowledge are applied into a working system that can then apply the knowledge to future cases. Rules, for example, you could encapsulate appraisal knowledge as a set of rules that such a system could kind of execute. Rules can be simple: if this, then do that. If I see these words or this metadata, or if I see something, then take a particular action. They're procedural statements. And it can be as simple as a saved search of some sort. So theoretically, if you save search terms and then re-execute at a later time, that's a very simple rule-based kind of process. More complex systems can comprise sets of declarative statements called facts and rules within a knowledge base. And applied to new input cases, an inference engine arrives at decisions based on outputs that are based on new facts. The thing about rule-based or expert systems is their internal processing, understanding their internal processing is quite straightforward. If you want to understand why a particular result was achieved, you can go look and see which rules were applied, and figure out how it kind of worked. If the answer was wrong, you can then modify the particular rule or rules involved, and then you'll get eventually, hopefully, the right answer. However, rule-based systems can be pretty brittle, and they tend to fail badly for problems even slightly outside their area of expertise. In unforeseen situations. So it might be that a new case that's not expected comes along and none of the rules apply, and you start to get kind of weird behaviours. So what you would do then is re-engage your domain expert to look at the new cases and kind of update your rule base, your knowledge base. But because this is time-consuming and expensive, it can be quite expensive to port rules engines from one context to another, because you've actually got to revisit all of the rules. And part of the reason for this is that rule-based systems tend to not learn. Right? So it requires an external human being to do the learning and place knowledge within that. And so for that reason, artificial intelligence research and practice has swung from these static models of knowledge through to systems that can learn. And so we then come across the term machine learning. And there's basically, again, simplistically, two forms of machine learning. The first we'll call statistical models. And how a statistical model works is you identify patterns in a set of input cases, and then you say, well, on balance, if I see these sorts of things, then they tend to lead to these sorts of outputs. Given a sufficient quality of high-quality sample, a sufficient number of high-quality samples, a statistical relationship between inputs and outputs can be developed. And I need to emphasize that it's a statistical relationship. It's not a rule. It's on the balance. Every time I saw these things, I tended to see those sort of outputs. And of course, the more data you can play with, the better your statistical model is. But instead of operating on raw data, inputs are actually translated into numbers, because you can operate statistically on numbers. And they're translated into a representation, a numerical representation of the data. And each piece of data is called a feature, and a collection of features is called a feature vector. Really cool technology, features and vectors. All right? So, for example, if you're looking at images, features are likely to be groupings of pixels or color brightness or edges, shapes, that kind of thing. In document analysis, features might be the existence and relative locations of words or phrases or other grammatical elements or metadata clues as well. But remember, statistical models don't understand the images or documents or whatever. The images or documents are converted into sets of numbers. The numbers are subject to statistical processing, and then the results are sort of translated back into our domain. So here's a slightly more visual explanation. The documents perhaps are represented as numbers. There's a machine learning algorithm that creates a model of some sort. Right? So the machine learning algorithm isn't the thing that actually makes the decisions. The algorithm is how the learning is done, how the numbers are turned into the model. Then later on, a new case appears, it's converted into numbers, the model crunches the numbers, and you get a result. So generally speaking, this is not the algorithm, that is the algorithm. I'll come back to that a little later. So the presentation of sample data to machine learning algorithms is called training. Training can be supervised or unsupervised, and I won't go into the details of that. And once trained, the model sort of runs. The domain expertise here, rather than coming up with a set of rules that are executed, the domain expert then selects the training data and some other parameters to come up with the machine learning model. The good thing about statistical models is that because they're statistical, they can actually give you a statistical explanation for outputs. So they may be able to rank things in order of probability or give you some statistical measures of that kind of thing. The common application of statistical models, there's basically two. There's one that's classification, which is our stuff. So given a whole lot of stuff and some predefined categories, which stuff matches which category. So you present it with a new thing, and statistically it works out which category it's in. The other application of statistical modelling is called topic modelling, where you actually examine your source data for structures and then come up with a set of categories basically for that information. An extreme version of that was the IBM Watson system that some of you may have heard of, that was famously trained on 200 million pages from 600,000 sources, including encyclopedias, dictionaries, thesauri, newswire articles, literary works and so on, and went on to play and win the game Jeopardy. Even though statistical models are difficult to develop and debug, they do provide this statistical ability to give you confidence in the output. But one of the problems is identifying what are the features that contribute to the statistical model in a meaningful way. So a further technique, which is called deep learning, allows the learning algorithm to figure out what's important in the input, the training data. So a human doesn't decide, well, it's these words or this metadata or whatever. You just throw the whole lot, essentially, at the machine deep learning algorithm, and it figures out what's important in order to maximize this statistical mapping. You need deep complexity for this, and so you need lots and lots of layers of processing, and each layer has lots and lots of processing nodes, and it starts to look like a neural network, which is like a brain, and that's where that terminology comes from. And in fact, we're going to talk about the difference. Some of our examples use deep learning models and some use statistical models. You need a lot of data for a deep learning model to do its thing and sort of figure out what are the features and then map them statistically to the outputs. In 2016, a rough rule of thumb was acceptable performance at 5,000 examples of something, and you'll match or exceed human performance with at least 10 million examples of stuff. So if you want to get human performance in item level appraisal, you need to label 10 million things and throw it at such an algorithm. Google Street View, house numbers, was initially trained on 200,000 street numbers. Deep learning systems can be even harder to develop and tune and debug than any other sort of automation, because you don't really know what the model's actually doing. And the ever-increasing number of layers, and state of the art at the moment is hundreds of layers, and nodes, millions of nodes, together with the complex interconnectedness, means that we really have black box systems. And again, they can be brittle. So here's the equivalent view where you throw your data at this deep learning algorithm that creates a kind of a black box solution, and then you throw a new document or whatever at it, and you get a kind of result. And finally, and I'm aware that I'm running a little over, it's just I'll say a few words about measurement, because it's important to know, is our initiative successful? So one of the terms that's often used is accurate. Our AI is 95% accurate. But what does that actually mean? And quite often we'll hear determinations are 95% accurate when compared to human results. But we don't actually spend a lot of time figuring out how accurate humans are themselves. So that's actually an important thing to kind of recognise. The metrics from information retrieval can help us here about precision and recall, and the incidence of type 1 and type 2 errors. If, have you decided something when it wasn't the case, or vice versa. And sometimes this can be expressed as an F score, which is like a mathematical mean of type 1 and type 2 errors. Confidence levels are quite important as well, saying, for example, I'll give you the example of the Google Street View project that said it achieved 95.64% coverage at 98% accuracy. So you got an estimate of what the level of accuracy was for how much of the data set. And interestingly, 98% was about the level of human accuracy at recognising street numbers. And the ranking of candidate outputs may also help in this understanding. So I think I've probably banged on enough about the theory behind all this stuff, and you're itching to hear about these people that actually are doing the work. So I'll hand over to Glen now, and he'll talk about his work at State Records and Archives New South Wales. Thank you.
I'd firstly like to acknowledge the traditional landowners, the Wajiri people of Nono Nation, and I'd like to pay my respects to elders past, present and emerging on land that was never seceded. I'd also like to acknowledge any First Nations people in the audience today. And I'd also like to say tēnā koutou, tēnā koutou, tēnā koutou katoa. Okay, so my talk is free diving into machine learning and records management. You might want to know why. It was 2 years ago I stood on the stage here speaking in the ASA on my dive into the digital archive. So things have moved along pretty fast. For me, now I'm talking about machine learning. Who would have guessed that? Why did we start this project? We were challenged by some senior management to look into machine learning, into records management in the field of disposal, around records disposal. And I foolishly put my hand up and said, I'll take that on. I don't know anything about machine learning or AI. The only thing I did know about AI was androids and science fiction looking for human consciousness. So here we go. So what we decided to do first was to do some preliminary research. And for me, that was what I needed to do was just go out and have a big, deep dive into that space. So I did a lot of Google searching, and I came across, where do we go now? This way, the arrows, yeah. Came across a little cartoon to start with, and as James Lappin is the cartoonist. You might follow his blog. He's over in the UK. My idea of this was like, yes, I answer the document you file. Like, I was thinking, no, it would be more like a Siri voice. It'd be much more sexy in that respect. Yeah, so I even contacted James to ask if I could use his cartoon. So I Skyped James and we had a bit of a chat what was happening in the UK space. He was based in Belgium at that stage. And because of the austerity measures within the UK, they were using more sort of analytical tools to clean up shared drives. There wasn't really much happening in the machine learning space, even though the vendors have tools that have machine learning. The vendors are sort of holding on to those, and the practitioners within the records area aren't using them. And his theory was that there was not enough case studies. There's not enough data around people using this technology in the fields of records management. He also asked what were we doing, what was our problem. Myself and my manager, Richard Lehane, were both sort of like, oh, right, yeah, we better start thinking about what we're going to do, and to write a series of blogs on our website, and maybe do a couple of case studies. One case study of data that we had in-house, and I'll talk a bit more about that later, and maybe sort of partner with an external agency and maybe a vendor. I also came across the hype cycle, and I thought this was quite interesting. This is the 2018 hype cycle, and you might notice that we're still in the peak of inflated expectations for machine learning, and it's still a blue dot, which is 2 to 5 years off of production. They've changed machine learning to deep neural networks or deep learning. So machine learning has actually changed its name on this one, the last year's hype cycle. And as you can see, we're going to drop into the trough of disillusionment very soon before we actually end out into the plateau of productivity, which is probably 5 years away. Okay, so part of my research was to look at who is using machine learning, and the big players, you know, Google, obviously, Microsoft Azure products, the cognitive services, and IBM. Anyone who's got a lot of data have been doing a lot of work with machine learning. Banking and credit fraud, discovery, e-discovery tools that we heard about this morning in Tim Gollin's keynote. The vendors, definitely, I had quite a few meetings with quite a few vendors in Sydney. Quite a few of them are talking about or have plugins with machine learning capabilities that some of you might be aware of. We even went to a HPE Trim Expo, which had a plugin for Trim, which is a machine learning plugin. But no one seems to be using it when I ask the vendors, like, who is using this technology? Government's using this technology. And I also got into a bit of philosophy and found a paper on realism. I wrote a blog that was on our Future-Proof website on that preliminary paper. It got picked up by IT News Australia, and after that I got contacted by even more vendors and got up to KPMG and also DXC, who are partners with IBM. Had quite a good few conversations. Through my research, decided to look at supervised learning to do my pilots, and we had a bit of stroke of luck. Fortunately for me, as you can tell, I'm an archivist. I'm not an ICT specialist. We did have a graduate program going with IC graduates, and just after I wrote my blog, IC graduate turned up who had just finished a module on machine learning for his degree. So I just needed really to explain to him what I was doing, what I needed, and he came up with our proof of concept. So the next few slides are his, and I'm having a caveat here that some of this is kind of over my head, but I am getting to understand it, and I think it's important that as archivists, we really do need to work with people with different disciplinary rights. Okay, let's move on. So supervised learning. So here we have the records people or the workers, and filing away their files in there and labelling them with their disposal and schedules. So they're all getting labelled. I get that data. I split that data through the model. 75% will go training, and we put aside 25% for the test. And then we get the 75% and we'll put it through algorithms and build a model down here, and then my 25% will go through there and my statistics will come out to show how accurate we went. We do some data cleaning. So here I'm going to remove all formatting words, remove stop words, the are, the buts, ands. There's documents that will not be able to go in through the model, probably usually because the text cannot get extracted, and everything is converted into lowercase. Tim talked slightly a bit about the vectorization, so turning all that text that we're extracting from the documents into numbers. We also use term frequency, inverse document frequency, to weight unusual or unique words within, and then they go into the document term matrix. So here's our proof of concept. So as I talked about, I had a corpus of data in-house, extracted the text into a CSV, the label and the text. We do our vectorization and processing, pre-processing, training, and in the end it comes out as a predicted class. For the first model, for the first pilot with this in-house data that I had, we decided to just use two algorithms, the multi-naive Bayes and a multi-layered perception algorithm, just to test the two algorithms and just to see how the results came out from those two. We displayed the results, as Tim was saying, using these terms precision and recall. And the F1 score is quite important to us to really see how accurate these algorithms are behaving. And sometimes we'll use a confusion matrix, which we'll see in a minute, that will display the results. So the pilots themselves, I was lucky enough to have this 30 gigabyte data from a central government agency, the department, that had not been sentenced. So I had to sentence it manually. I don't know how long that took me. I should have really took a time frame, but to sentence digital records when you have to go down sometimes 6 to 8 folders to get to the document that you need to look at to sentence, it can take quite a lot of time. We used our General Disposal Authority 28, which is all a government record disposal authority, and I chose just to use the 23 archive classes because I was interested in just trying to find an algorithm that can just give us the archives from a clump of data or a clump of records that aren't sentenced. So I was really just looking, in my first thought of this pilot project, I was just thinking, I just really wanted to try and find the archives. So we used the classes, and we ended up with 12,000 files. Only 8,000 of them were able to be used because we needed to get the text out of them. So photographs, unusual graphs, and so forth can't be used. The second external pilot was with our Department of Premier and Cabinet. It was a much huger corpus of data, 81 gigabytes. Both these were from Objective. It was multiple classifications, so much more complicated. And also we had an XML output of just metadata for their physical files that had been sentenced. So we really wanted to try the algorithms on just purely structured data rather than unstructured data. And it was a much bigger corpus of extractable text. So this is the results from the first pilot. And straight away you can see the multi-naive Bayes algorithm is producing a poorer result than a multi-layered perception algorithm. So just looking at the F1 scores from sort of the 60s and then into the 80s, which is quite a reasonable result as we thought from the first pilots. And seeing that displayed in your confusion matrix, this is not what you want to see. This is kind of underfitting. So basically this class here is just pulling all it into this predicted label. So down here we have the predicted label that's coming out from the 25, and this is the true label. We should really see something more diagonally, like this, showing great hits here. You might wonder what these two are floating out here are. These are floating out because there was one single file. So not enough data for the algorithm to behave as we want. So we're sort of trying to manipulate the data to get the best results as we can. The external pilot, we had a whopping 97%, which was like very shocking for us. And the reason of that is that 2/3 of the data, over 60,000 of those files were sentenced with one class, totally skewing our results. So ended up thinking about moving that class, so we dropped down to 30,000 files only, and you see my accuracy really dropped down to 61. The reason for that is that I also had a lot of files in there that only had classes that had one or two files in that class. So then I decided to take only classes that had 200 files in them without the FA202, and I'm getting a kind of reasonable result of 68 or a F1 score of 70. And here's the confusion matrix, and there's our red herring. 13,993 files getting pulled, and see the little clustering happening around there. If we had more time, as I said, this was a side project to my BAU work. I had an IC graduate working with me. We didn't really have enough time to sort of fully analyse why and how all these are happening out here, what words making them go there, why is always a question still happening with me. So, and final, to wrap up, that there is potential. I've written 3 blogs, probably better than me speaking. It's probably better to read my blogs on the Future Proof website. Just type in machine learning, but maybe a bit more understandable. But basically, the comparable results are very promising, and it's only 100 lines of code in Python. We used scikit-learn, which is an open source machine learning library, all written in Python. The code that we wrote to run these tests is on GitHub. Expertise to me comes with a group of people. So I had knowledge what I wanted, I knew what the results I wanted. I was sort of the subject matter expert within the sentencing of records. I had to have an IC graduate. We needed to do project management around this. We needed large volumes of power within the CPU. The corpus that you start with needs to be evenly labelled and representative. Further research we need to do a lot more future research. Human input is muchly needed. I'm not even touching on the ethics and bias that needs to be discussed. I've got hopes that this might inform us with future appraisal, and I also think that we really need to re-look at our tools, our retention and disposal schedules, and I think maybe machine learning may inform us on those things. So I think I'm going to run out of time. And I'll hand over to Lisa.
Thank you, Glenn. Before I start, I would like to join with our hosts in acknowledging the traditional owners on the lands on which we meet today, the Noongar people, and pay respects to their elders past, present and emerging. I'd also like to acknowledge the people of the Kulin Nation on whose unceded lands the offices of the Public Record Office are located and where this project was undertaken. So you probably have heard of the Public Record Office, but the Public Record Office of Victoria, or PROV, is the archives of the State Government of Victoria. I'd better put my presentation. Oh, no. There we go. Sorry, now I'm ready. So PROV holds around 100 kilometres of records dating from the 1830s to the present day. I'm here to talk to you about a proof of concept project that PROV undertook in late 2017 to test machine-assisted assessment of email for appraisal and disposal, with a view to disposal. I was engaged at PROV late last year, early this year, to work on this project, but prior to that I worked for several years in both the state and federal government and in the private sector. And what's become clear to me over that time is that while many organisations have large volumes of information in paper format, which are really well managed, many struggle with the digital equivalent. The tools we've developed to deal with the paper world in some cases don't apply or are of limited use in the digital world, which is why I was keen to work on this project at PROV to start to explore new ones. So our problem began with a large backlog of email. So over 20 years of routine backup had resulted in an unwieldy backlog of Victorian government emails, including 67,000 tapes, physical tapes, on which the backups were stored, plus around 8 years worth in online storage, so approximately 28 petabytes of content all up. The backlog is managed by the government's shared services IT provider, who also support the email tool itself, which for our sins is still Lotus Notes. Email, like any other record, shouldn't be disposed of until their value and content are known, but in the course of their work, public sector employees can generate hundreds of thousands of emails, including emails that don't need to be captured or kept long term. The large volume of emails involved in even a single email account can make it difficult to identify those that we do need for ongoing retention. The backlog's a problem because while the storage is cheap, finding the needle in the digital haystack isn't. Agency requests to the IT provider to retrieve emails from the backup take a long time, and that's especially so if they're on tape, and it's a service that the agencies have to pay for. They then have to spend time trawling through the emails that they actually get back that are restored. So it's definitely not a cheap option. And actually on that, it's often said that storage is cheap, but the move to the cloud, which a lot of departments are now making, is actually highlighting to agencies that storage isn't as cheap as it appeared when the IT provider was actually carrying the cost for them. So there's a bit of an impetus there. So why haven't agencies just disposed of this backlog? And there's a few issues. The first being that agencies aren't confident that valuable emails have always been captured somewhere else. So they're not confident that, for example, staff have moved them into their EDRMS system, whatever that is. So they're reluctant to delete it. It's kind of become a default source of record for them. Secondly, we just don't know what's in this big bucket. We can assume there's a mixture of records, small percentage of permanent, a larger percentage of business records, and also some non-records. But as they're all public records created in the course of the agency's business, they can't be disposed of without proper assessment. And this is difficult, both because of the volume of emails and because the contextual record keeping metadata that aids appraisal and disposal is missing. So while the email themselves are quite metadata rich, for example, you get to and from, you get titles, you get the keywords themselves, dates and times, they lack the high-level record-keeping metadata that might allow us to group them into useful chunks for disposal. And we certainly can't do it item by item when you're looking at 28 petabytes of data. So the agencies have a problem and a risk. They can't get rid of their backlog and they can't easily use it either. So not only are they not getting value out of their email, but it's actually costing them money. So the purpose of our project was to see if we could use an e-discovery tool to assist with assessing the backlog of email with a view to reducing the volume via authorised disposal. And in the Victorian Government, that means in line with retention and disposal authorities. Okay, so our approach was to find a partner agency who is interested in exploring a solution to their problem and who would give us a sample of their email. The second step was to find an e-discovery tool to see if it could support review and appraisal activities over the large volume of email that we had. The tool had to be able to ingest large volumes of data quickly and have a robust search capability. We selected a tool based on recommendations from another agency who use this particular tool day to day in their investigative work. So they use it as an e-discovery tool. We were sort of trying to use it for something slightly different. Just a really quick definition before we go on. E-discovery, in this case meaning electronic discovery, refers to the processes involved in identifying, collecting and producing electronically stored information in response to lawsuits or investigations. And the e-discovery tools are developed to support these activities and so far largely used in the legal sector. So, from our partner agency, we received an email sample of 1.5 terabytes, comprising 1,479 individual email stores. Generally, there will be a store per person, but there will obviously also be generic email accounts that will also have stores, so it's a mixture. They contained 33 million individual items, so the items in this case means emails, attachments, notes, calendar reschedules, etc., and 4.6 million actual emails. We wanted to test the e-discovery tool's out-of-the-box features, as well as testing out some business rules that we developed to mimic high-level assessment activities. Behind, there we go. One of the out-of-the-box features we were really keen to test was the deduplication function, which we hoped would be a simple way to reduce the volume of emails and is in line with the normal administrative practice, or NAP, that exists in the Victorian Government to get rid of ephemeral emails. So, next what we did was develop 3 business rules, 2 to reduce the volume of emails and 1 to slice and dice the bucket of email. The negative approach, the focus of the negative approach was to reduce the volume of emails by identifying non-records. So we did this by reviewing the domain names contained within the email set and identifying those that we thought were likely to be the source of non-records. So for example, those starting with no reply or info or notification, so no reply at Facebook or notifications at Facebook or something like that. This also allowed us to exclude whole domains, so by that I mean domains that send email in and would be received by staff. And some of these include footytips.com.au and hotbargains.com, because apparently if there's anything us Melburnians love more than football, it's bargains, so that was useful to look at that. It also allowed us to identify specific email addresses that were responsible for large volumes of automated notifications, such as the HR system, so we could exclude all of those as well. So we ended up with a whole raft of domains that we could essentially use to exclude certain emails. We did try a few things that didn't actually work. So we tried to use lunch as a search term. If anyone's ever tried to organise lunch via email with more than 2 people, you get an idea of how many emails that can generate. And we found many emails that were sent and received trying to do just this. But we also found enough emails that related to lunches being arranged with ministers and other dignitaries, so we couldn't actually use that as a criteria to exclude emails. We also explored the use of security classifications, and in this agency an email can't be sent without applying a security classification, one of which is unofficial, and that's for emails that are not work-related. So we reviewed all of the emails that had been tagged unofficial, and unsurprisingly there was a lot of stuff that was probably unofficial and some things that weren't, so we couldn't use that with any great confidence. The next one was the positive approach, and this is the approach that really is, it's what the tool is designed for. You give it a bunch of search terms and it goes out and brings you back the relevant material. We defined 3 types of search terms. The first, which is social, which is similar to the capstone approach in the US, if you've heard of that. It's based on the person's position within an organisation. So we picked just picked 8 of the top highest ranking people in the department on the basis that their titles would be within the email. So we use those as criteria. Action type, for example, things like reports, deliverables, minutes, and a semantic type, which is keywords. So we put all these together in one big search query, basically. The third approach was the macro approach, and this wasn't about reducing the email sample as much as it was applying more metadata that we could use to assess these emails. So we had a lot of names. Each email box basically has a name. So we did a bit of a data matching exercise between the org chart of this organisation and the names. And doing this, we were able to apply 2 extra fields of metadata to every email, apart from the generic email boxes. So each email then had 2 levels of org structure attached. And that could be used for appraisal. Potentially. It's not perfect. So you could potentially choose to keep all of the emails that came from your core functions forever, and all of the emails that came from your corporate functions you might want to keep for 50 years, something like that. So what did we find when we actually tested our approaches? So running the inbuilt deduplication function identified that approximately 43% of the email set was duplicate, and that's exact matches. This is we thought this was a great result, as the function doesn't really require any prior setup or any prior knowledge of the organisation, but it does reduce the volume. When we ran the negative approach, we found that 7% could be excluded as non-records. This is with 100% accuracy, and also a pretty good result. When we ran the positive approach, we found that we actually received back 93% of the data set. So that's saying that 93% of the data set was positively identified as records, with 98% accuracy, so not bad, but not as good as the other approach. It should be noted that these results are from a fairly conservative approach, which could be increased by being a bit bolder. So for example, we ran exact duplication. You can run near duplication, which is letting the tool say, okay, these are the duplicates, and then these are the things that look like the duplicates. So based on these results, our conclusion were that this is a viable approach capable of reducing the volume of email in a backlog significantly, using pretty simple steps that a non-technical member could implement, and that is me. I'm the non-technical member. I don't come from an IT background. We did have really great support from our vendor though. So she sat with me and did it, and I would say at the end of that I would feel fairly confident in then going and doing it myself. So it doesn't require a great deal of technical skill, which is lucky. The results indicate that our approaches were pretty accurate, but we did only test them against a manually appraised sample of 100 emails, which is a drop in the bucket, so that's definitely something that needs to be extended. Our recommendation would be that if you were to use this in a real life situation, that you would run the deduplication, so cut your thing by about 43%, run the negative approach to reduce a further 7%, so cut it in half essentially, and then potentially use the macro approach to slice and dice the bucket. We wouldn't really recommend the positive approach because it's just not accurate enough, and it's very, very difficult, and it really did highlight the challenges in trying to do contextual searches with this tool. Access was a challenge. Getting access to the emails themselves was a challenge. The department was a bit toey about that. We signed non-disclosure agreements and things, but they were still a little bit reticent to give them to us. And at one point we were allowed to have the email, but we weren't actually allowed to look at the email. So that might sound a bit funny, but it does illustrate the challenges around email, particularly as a document type. They're very important records. They're sent from every single level of an organisation. They are key to making decisions and implementing actions. But on the other hand, they're often short and casual and offhand, and I think everyone's probably had the experience of sending one that they wish in retrospect they hadn't. So they are public records, but they're also very private records. And as work and leisure time continue to overlap with increasingly mobile and connected workforces, this will only increase. The emails provided us with challenges now, but also into the future, because PROV will need to consider how it provides public access to emails that are a mixture of personal and work matters, and how it manages access to emails that are sensitive, either due to the subject matter or the persons involved. Thank you.
Do I need to press something? Okay. All right. Well, there is one slide, but one of the points I'm making here today that I don't have a presentation. And at first, I had a very busy time leading into this conference, and I thought, okay, well, my excuses, I was too busy. And as I was starting making my excuses to Greg, apologetically, then I realised that, in fact, I didn't want to make a presentation about this, because I've been on the project looking at use of automation and machine learning for archives for a while, and haven't quite plunged into that Gartner disillusionment yet. Kind of feel a little bit sliding down there, because the more you see, the more you know, the more kind of dissatisfied in a way you become. So I kind of didn't want, I could have thrown in, I've got a confusion matrix, I've got some Venn diagrams, but that's not what I wanted to present about our project, kind of just to indicate some emotional toll that could happen, could be taken on people who work and look into this. So for some time, the National Archives of Australia has been researching possible approaches to using automation and machine learning for creating and executing disposal authorisations for appraisal and selection of records for preservation or destruction. So in a way, our primary goal was to transform disposal schedules, we call them records authorities, and not to do something practical as sentencing records. So it's kind of a little bit different from what the other colleagues looked at. This research started in 2013 and was carried over intermittently with a change of focus from a desire to find a new magical format for disposal and retention schedules. The focus now changed to our current work on applicability of findings of our research for the use of the archives itself as an agency for its own corporate information, and to try some of the assumptions in practice on our own records. And it kind of also happened that the area where I started through a couple of changes within the organisation became responsible for our own corporate information and our record-keeping system. In 2014 and 2015, we created a conceptual model of the disposal authorisations, or Machine Executable Records Authority, as we called the project then. The model was technology agnostic and was intended to design a schema representing machine executable disposal instruments, that is, those that would be able to match a particular record to a particular and appropriate disposal class. It was purely theoretical, with not much understanding of practical implementation, and that kind of raises another question, sort of the role of data modelling, because we've got the model and people looked at it and said, yeah, okay, looks good, but kind of, so how does it work? And we had no idea. We made just some assumptions that, well, technology was available, we read all the news, read all the blogs, and heard about Watson and whatnot. I thought, okay, we'll just build the perfect model, use the perfect technology, and it'll be fine. So this initial inquiry was transformed into an ongoing research and development project. A team of 4 people from different sections now has been conducting research on a very, very part-time basis in 2015 and 2017, and went through various learning processes. We met and talked and sometimes engaged some of those consultants and vendors. We had some workshops run by them which helped the team to become familiar with available technology and to test theoretical and methodological approaches to appraisal. On the way, we looked at entity and automated metadata extraction, semantic analysis, taxonomy and ontology building, linked data approach, and most recently last year we looked at the work done internationally by World Wide Web Consortium with their provenance data model, and also the ICA's records and context conceptual model. So that all stimulated our thinking and led us to try out semantic analysis of language used in our disposal authorizations. In 2017 and 18, the focus was, as I said, on how the archives itself appraises and sentences its own records. We turned to our own disposal authority that was issued in 2007 and now requires a review. We recommend to other agencies that they should review their disposal authorizations every 10 years, so we're now overdue ourselves. The format of our disposal authorizations also represents a traditional archival tool designed within and for a paper-based environment and with the intent that humans will execute any decisions. So we didn't want just to go and review our authority the usual way as we do with the agencies. We thought, well, could we implement some of the findings about technological innovations on the way? And it's kind of sort of time passes quickly, nothing terribly interesting happened. And a bit earlier this year, we finally got a couple of machines. So we built a non-network test environment to try out things. So as you can see, from 2013 to 2018, we kind of struggled with the ICT governance processes. And anyone who worked or works in a government department would understand and relate, I'm pretty sure. So from about March and April this year, we ran very quickly a number of concurrent trial projects. Project 1 was an in-house trial of text mining and machine learning methods. It was an experiment run by a team member with a very serious computer background, but also was helped by a practicum computer sciences student. Students are very useful, aren't they? You don't have to pay them, and they do stuff for you, and anything else you tell them. So, and our student, were very lucky. He actually was interested and specialized in deep learning and neural networks. So we thought, oh well, we'll snap him. We had a demo license of a software package to use and to understand the general text mining space. That was the first initiative we had. So we used QDA and WordStat software, extracted n-gram word combinations from our own records, about 100,000 individual documents from our corporate EDRMS. And then sort of, again, the computer guys did some magic, cleaned up, reduced the noise. And these now resulted in a list of key phrases that were exported in order based on an importance of weighting assigned by the software. And what we did, because the 100,000 documents, they already sentenced, so they already have disposal classes attached to them. The records go back to mid-90s and stop about 2010. So we had a good sort of pre-labeled training set, to use the technical terms here. So, and the records, what we concentrated in our research, instead of going straight down to the classes, because we wanted to review our records authority, we looked at functions and how accurately functions could be identified for individual records. So now we have for each function a set of lengthy keyword phrases which theoretically they were extracted from the records assigned to them, should represent these functions. What we're now looking at analyzing those lists of keyword phrases and comparing to our functions and disposal classes to identify whether a mapping could be done and our disposal authorizations could be applied with their help. And we can also trial their use for the development of our internal ontologies and controlled vocabularies for possible metadata enrichment and title improvement in EDRMS or for reviewing our records authority. This first experiment was complemented by the use of machine learning algorithms to replicate and hopefully to improve the text mining results. Our colleagues from New South Wales, thank you Glen, thank you Richard, because they've already done this stuff, so we thought instead of doing the same thing ourselves, we'll just use and reuse. So we've reused the code and we're able to reproduce very similar results of classifying records against our own 15 functions. And yeah, that's kind of the point of difference. We didn't do the classes, we did the functions. And then we trialed an extra algorithm itself. So in all, we used as well naive Bayes classifier, the multi-layer perceptron, and then our student, that's where they're handy, he just threw in a support vector machine algorithm. So we beat you guys. But okay, well, we beat you, but with what results? So what we found, that text mining and naive Bayes produced very similar accuracy results, about 74%. But when we used machine learning algorithms, our accuracy results bumped up a little bit to 84%. There was a little bit of difference between how different algorithms work and how much time they take to be trained. We split our data 70 to 30%, so 70% of our data was used as training and then used 30% of the rest data to match the accuracy, to identify the accuracy. And for example, for 75,000 documents, the multi-layer perceptron used 10 minutes to process, but the support vector machine algorithm took about an hour of process, but then it had some other technical benefits. It just shows you these things, they kind of work similar, produce similar results, but then you can manipulate them. You could throw in an extra data, and that's one of the results that our student found, that we trained one algorithm on a very good data, which should produce very accurate results. But then when you feed a little bit of lower quality data, the algorithm gets confused and the results get diluted, and we don't quite understand why. Yeah, there's a lot of things there. Stuff happens. You add more records, you take a few records out, and the results are significantly different, and it's hard to explain. And I think you guys in New South Wales found something similar. But sort of from our student, the recommendation from our computer science students not exposed to the archives before was that it did look like the algorithms could help alleviate the load for manually classifying digitally born documents. But at this stage and with this particular corpus of records, an archivist should not be solely reliant on these algorithms. With ever more complex algorithms, a true ability to match human level classification will be met. 0, 5. Okay. And there were a couple of other projects that we had, and there's not terribly much to say about them because we're in the middle of them, and that's why I didn't want to have any visuals. One of them is event engagement to understand and to develop knowledge graphs. This is a sort of a graph database search platform near 4J, and some of you might have heard about those and about creating knowledge graphs. So this was an example of engaging with a vendor who says, yeah, we'll come and solve all your problems, but it's a black box approach. We don't know how it works, what algorithms they're using. So we're still in the process of working with them, trying to understand what results they can throw in and whether they can explain how that works. The other project was an academic engagement, kind of said, okay, we'll go back to ground zero and do it academically correctly. So we engaged with some academics from the Research School of Computer Science at the Australian National University, purely computer scientists, and we asked them to help us to identify relevant machine learning techniques and technologies, explained our problems as well. So they ran a couple of workshops with us using Kana method to identify opportunities. Then the second workshop was on value-sensitive design, and they talked to us about the other previous projects in machine learning and clinical notes taking in the hospital industry, so, for which they claimed they had very high results of accuracy and very useful to use. So what we came up with, what we want to do next is they suggested we establish an annotation project, so kind of like create a training set with the humans contributing to that. We're going to look at the records, develop the guidelines on how to annotate the records. This will be a semantic analysis to try and to understand the use of the terms within our records and within our records authorities to identify the meaning and try to automate the implementation. what have we learned while doing all of this? We developed a greater understanding of the statistical and cognitive computing methods to process document content for automation purposes. We confirmed that existing capabilities of archival and information management professionals with our controlled vocabularies and metadata can be built upon to aid adoption and explainable machine learning processes. Because of the reliance on data as a source for machine learning, an increased focus on capabilities for data literacy and governance is needed to trust the data sources, how the data is transformed for machine learning processing, and how machine learning outputs can also be trusted. We informed ourselves how natural language processing works and that it is a key for future adoption of machine learning. We learned that use of graph databases to query large unstructured data sets can help classify information, but it is yet to be proven that we can trust automation completely for determining the significance of records, although there is a lot of evidence to suggest that algorithmic classification could automate the identification of topics most likely to be significant. And at the end, we tested in-house specialist skills required for machine learning practice, which can be drawn upon to understand how machine learning specialization could be developed by others. Thank you.
Thank you, Tatiana. So, AI in the archive. It wasn't explicitly said, but we heard examples of rule-based systems and statistical models and deep learning systems. But one of the common features of all of those is the difficulty in asking the right question of the automation. What is it that we actually want to do? And we have three institutions that asked vastly different sorts of questions and got some interesting answers. The technology used in terms of buying the iron to do the work is interesting. One of the things that State Records New South Wales struggled with a little bit, which we hadn't really touched upon, was the use of tools that live in the cloud, like Microsoft's tools or Google's tools or that kind of thing. And so that's a question to ask. There's significant upfront cost, particularly as you might have gleaned in the collection of data for training and testing for these models. And the brittleness of the models, as we've heard from many people, of taking data in and out and not being able to explain what the results actually mean. For me, one of the most important features of all of this was the need for us as record keepers to kind of embrace this technology. And in the same way as we've had waves of having to understand the web and the semantic web and other technologies, I think this is another sphere that we'll have to kind of embrace for a couple of reasons. One, we're going to be getting records that are created by this stuff, so we need to understand how they've been created and what the provenance is and what they mean. We don't want to be dazzled by vendors. So we need to be able to have intelligent conversations with them as well. And probably just as important, we need to, and I'll use the Microsoft term, we need to be able to eat our own dog food. We need to be able to document our record-keeping processes. And the volumes and complexity is such that we're going to have to be using these tools, and so we have to really understand of how we can justify and document what we're actually doing. I was going to mention this at the start, but I completely forgot. We have written about this in far more detail than you probably want to know in Archives and Manuscripts, and it was actually going to be in the July issue, but it missed, but it will be in the November issue as well. So there'll be in the article, More Human Than Human. So in a few short months now, it'll be published and you'll be able to look at these case studies in a lot more detail. So, at this point, we've got some time left. Are there any questions of our panel? We have some microphone runners. Glen, do you want to switch the mic on and in anticipation?
My name is Rosa Malone. I'm the archivist at Cathedral Grammar School, and I'm you mentioned that certain models of machine learning don't understand, you use the term understand, the document or images that they are processing. And I noticed when I heard all of your situations, your case studies, that the problem that you had each time was with unstructured data. And my question to you is, in all of your experience in this project, or these projects, did you come across any trends or pointers or technologies that you thought in the future might understand inference, relations or variations in records and archives for future processing? So in other words, understanding the document or the image more.
Thanks, that's a really interesting question. I'm not sure about understanding as such, but I guess maybe a related issue is one of the things that we found with the e-discovery tool is that context is actually quite hard to search for. So for example, if we were looking for all of, we did try this, look for all of the records, for example, that went into creating a policy. So, you know, people discussing the policy by email, sending around for review, all that kind of thing. It was actually quite hard to do because some people send emails that are literally 3 words, and the title will be meeting Monday, and the email might say, yes, go ahead as per our discussion, and they will know what that's about, but you can't. So without those really strong markers within the documents themselves, it is very hard for the systems to even know what they're looking for, let alone to understand what it is that they see. So there's things in e-discovery tools such as hotspots, and my understanding in a very non-technical way is that you can run it over a whole group of information and it will itself pick out, you know, areas of interest or where there's a lot of activity in terms of keywords. So I can see that as being something that we as archivists could use in the future to actually surface issues and things that we might not see or we might not expect, but that the data will tell us. So I think that's a really exciting thing to look at.
That's very exciting. It sounds like it comes down to asking the right questions. Thank you.
I would just like to add to that. I can't resist but to, mention this is the Iran-Contra scandal. I don't know how many people in this room are old enough to kind of remember that, where the smoking gun email was well done in the context of everything that happened. So sort of, for me, capturing the well done email is possibly a benchmark of this sort of stuff. Anyway, we have no question? Oh, okay. So down the front here. Joanne.
Yes, Joanne Evans, Monash University, and I work with Greg, so to explain that context. And yes, I don't want to derail, but it is a question. It's not a technical question for the panel, but it's about the socio-technical side of this, and it's about the role of collaboration across jurisdictions to address these issues. Because I think we have got it really wrong with digital archives, because we have every single archive developing their own bespoke digital archives when actually they're dealing with the same sort of stuff. And so how can we learn from that experience to make sure that in this world we actually start the collaborating now, instead of everybody doing the same kinds of experimentations and coming to the conclusions? So what would be the social things that now need to happen in the archives and records communities to take the promising work you've done forward in a connected and coordinated way?
Well, we actually kind of started cooperating, and the reason I know what Lisa have done and Lisa has done and Glen and Richard did, because a little bit earlier, or was it last year? Yes, it was last year. Sort of in terms of government archives, we kind of organised a little bit ourselves through the ADRI, Australian Digital Records Initiative. We suggested a project to lead with the State Records of New South Wales, State Records and Archives, I think you're called now. So that, in a way, Greg kind of gazumped our ADRI project, but we're very thankful to him for that, I think because he organised us a little bit more. So we sort of identified the need to look around, sort of kind of identify a bit of a research agenda or machine learning use and automation use in the archives. So we established this project and got together, talked about our case studies and sort of planned how we could sort of maybe write a paper and publish the results, sort of identify what things to have been tried, what needs to be looked at, and kind of we're sort of doing that more or less on a part-time basis again as BAU, and then Greg kind of sort of talked to people and sort of said, okay, all right, well, we can report this activity on the article in Archives and Manuscripts as kind of a tick in the project as well, but we will have another report based on our conversations and our thoughts and other things that we've done, and also identified some other things. One of the things about machine learning and AI that kind of bothers me and kind of I think bothers a lot of people, it's that explainability of it, how it works, because if you want to be accountable on why the records are destroyed, for example, so if we use it for appraisal and disposal, how can we be accountable if we don't know how the algorithm that made these decisions works? How can we do that? So what can be done into that? But apparently on the broader scale, it is a more often spoken item now itself, kind of the first doubts we had, but the IT community itself is talking about this, and AI specialists are talking about that. So we kind of identified that. So the need for governance, how you prepare your data, is there any bias in your data? So there's a lot of things that came out through thinking and discussion. So there will be something. We plan to publish it on ADRI website, and yes, we'll try to sort of send it broader to the community. And yes, yeah, we're happy to cooperate. And in fact, it was very good actually to start talking. Oh yes, and you do this. Oh, and you do this. And in fact, even before that, the colleagues from New South Wales came to Canberra to talk about us, because I don't know, you heard something about between. I'll just get over to Glen. So yes, you're quite right, Joanna.
Yeah.
We shouldn't redo stuff, and that's why I said we didn't want to just to redo our own coding, we just wanted to use what I used.
Yeah, I think the collaboration is key. With the question around digital archiving and bespoke systems, I think it's a bigger problem and very difficult to collaborate across jurisdictions. And the main reason, I think that one of the things that I think what we do need is a lot of classified data. So text documents generally, and the response I got from once it was published on our website, I was getting tweets from overseas that the problem with machine learning and text is there's not enough classified text available for people to play with, and a lot of that is because it's locked down by government and not been released to be able to produce better results. What I'd like to see in New South Wales is that we could share our general records, GA28, which is our General Disposal Authority, across all clusters, so then we have a bigger amount of classified data to produce a model that will maybe help government. That's a dream, I think.
From my perspective, I think we have an enormous opportunity here. In Australia, we all sort of, jurisdictional standards aside, we all think in the same sort of way. And so theoretically, we would hope we could do such a thing. And so I think the sum could be greater than the whole could be greater than the sum of the parts in this sort of space. But Joanne, you wanted to say something else?
I was just going to follow up on that. Yes, that issue of having those shareable data sets is a really good one, because I can, way back when I was doing some IR work, information retrieval, the TREC databases that they had them, which had their problems, but I was aware of that, and I'm also aware of that sort of stuff in the software engineering field as well too. So that importance of building that, I think the ADRI stuff is a big difference to the early digital archive days, having that structure to bring people together. But I think it's also building those kind of shareable other resources to support that work, I think, is actually where some of the strategic and managerial work needs to happen in this area. So I think, yeah, that's a good one. Yeah.
Okay, so in summary, there's this wonderful quote from Roy Amara. We tend to overestimate the effect of technology in the short term, and certainly the vendors would have us think that, and the Gartner hype cycle, and underestimate the effect in the long run. So I think this is going to be more profound than we can possibly imagine, but it's going to be a long journey getting there. We may be human, but the AI discussion has begun, and we will all need to join in. So can you please join me in thanking our panel members, Glen, Lisa and Tatiana. Don't forget, there's merchandise to buy and drinks to sign up for at the registration desk. Thank you very much.